Good morning and welcome to Science 9 in the AM. We just heard from one of our students. Big thing here is to change our question that we're answering into a statement that's not a question. We call that the purpose of the lab. It's really to answer a question, but we discovered that if you have a question, what happens when different objects, charged objects, are brought close to the electroscope? If we just add a few words ahead of that, it becomes a statement that we can call the purpose. To determine what happens, blah, blah, blah. And then pretty well the same thing without a question mark at the end. Or to find out what happens when. It's important that we know how to create a purpose for our activities. Now, and we're using a procedure in 214. Oh, what am I doing here? Sorry, I accidentally, it's one of the, he's a ranch teacher. Don't worry about it. I just accidentally hit paste, and I was sending in an email earlier. This is what I meant to do. And then materials and procedure refer to 214 data. So I guess we should turn to 214, eh? And I'm going to stop the recording. And for those of you on the recording, this lab doesn't do much visually because it's only through your screen. But as we take stuff up, we might. Just reviewing what we saw the other day, guys, because we're doing something with the electroscope on video now. We've got a negatively charged balloon. I bring it close to the wall and it sticks. But watch what happens to the electrons on the wall. What is the word for what's happening to the electrons on the wall? Repelling, yes. And as I move it, those electrons, they're movable. The positively charged protons are fixed. They're not going to go. So, thinking that through, what's happening when the balloon gets close to the electroscope? What's happening to the electrons at the tip? Right. There's more positives than negatives at the top, right? There's repelling them down into the leaf. So what's happening in the leaf? I call it, because it's a foil leaf, is what they call it. So there's still a positive here. There's still a positive here. But these electrons have now scooted down. So that, yes, there's positive here, but there's a couple more electrons here on the leaf, and then they are repelling each other at the bottom. Then I take the balloon away, and those electrons go back to where it was. If you got it super close, though, maybe some electrons have jumped into there. But that's not what we're focusing on first. I am going to, is there any discussion or questions about that kind of idea? I told you I have a better diagram, but I wanted to reason it out with you. This is probably what we're seeing here. And slide 14. Come on, machine, work with me. Okay. Data. Now, I used a rod, same draw a circle with the balloon, a negatively charged rod there. Well, we're using a negatively charged balloon. And it chases the electrons. I got that in blue on the diagram. Right? It's a better diagram, would you agree, than what I have on the whiteboard? That's why I said blue. These ones are silver leaves. The other year I had gold colored ones. So there it is. They separate, right? Before. This is your data. Your data is a diagram. This is your before. And then after you remove it, the charge rod is being taken away. The foil settles down, goes back to normal. You'll notice that the electrons are spread evenly throughout. So this is sort of a neutral thing. So it's sort of making a. Oh, anyways, I'll just shush and let you guys jot this down. This is your data. You need this because you're doing a write-up. We're doing this activity instead of just reading and thinking that science is just about reading textbooks. We're observing. I'll pause the video. Let's talk about this conclusion together, because we learned something about we learned something about electricity, static charge. When a charged object is near the electroscope, the lead segment, and here's the word that I want you to know, induction. Then we're going to play around, stretch this level. Yes, I'm giving you this, is what I'm telling you. I'm just going to do a two-mark check visual for this one, as in, make sure you lock this down. Underline the word induction because I want that in your head. And actually, I got ahead of myself. We didn't do the contact. It's down there, and then we'll go back and figure it out. But this is something I did up with my other students. Probably the last time we wrote this out was 3 years ago. It was the year that COVID shut down our schools, 2020, so 3 years. And it was the first unit I did. And in March, remember how you guys got sent home? And it was like a sad day. Those students just graduated. And then, yes, I told you I got ahead of myself because he got excited here. We still got to do the contact bit. I'm also very cognizant of the time. Normally, I would get you guys to. Oh, that's because it's frozen. There. You know, I underlined it 4 times while when it was frozen. And some of you have already seen the charge by contact, and I said, well, just rub the thing a little bit here. We're going to play around with that. So I gave you the results before you did this thing. But I think we're still going to play around with this. As you're jotting it down, I'm just going to think about static electricity and where you might have heard. Has anybody ever built a computer or helped someone else, an older brother or sister who had the money? Yeah, you built a computer. Did you take any precautions because of static electricity? You should. Anyways, if you get computer stuff done, people who work on computers take precautions because you can ruin the chips and stuff with this static electricity. Yeah? Yeah, that was what they came up with, sure. And I was going to subtract that. And I got this out of order because we still got data. There was a possibility of error. Many people had statically charged hair or clothing on that day. And there was, actually, I remember that day was a staticky day. It was a static day. Yeah. Because typically in a conclusion, you answer the study question, but it's a purpose, but you address the purpose. And then you talk about any error analysis. If there's numerical data like measurements, you can talk about that. Like maybe our times were too short because we hit the button too quick or something like that. Things like that. On this particular one, that was the source of error that students came up with. Because we were getting screwy results. Today here, not an extremely static day because it's humid outside, right? Rainy. So we got this statement down about the charged balloon. We've got the diagram, contact electroscope. There's a few other terms that we need to just understand now that we've talked about it. And what is meant by induction, grounding, and electrical discharge? And it's all in handwriting, so this sucks, right? So I'm going to type it over. If you could get a start though, charging by induction. Okay. I'm going to just retype it at the same time, and it'll be replaced. And I'll replace it. Okay, I'll get rid of the beautiful handwriting. Your grandparents would be impressed if you guys had handwriting skills. But whatever. If you're lucky enough to have grandparents. Not in this year. Son of a biscuit. Never. Electrical discharge. When electrical charges are transferred. Grounding is what we were doing by touching the knob, right? You are connected to the Earth's surface, and somehow through the building, through the floorboards and stuff like this, the extra electrons are dissipated or gotten rid of, right? We know it had a negative. There we are. You guys have that. The bell is going to ring, and we're going to call